Okay, so in our last video, we're going to look at is the ARIMA model. Like I said, this is a very popular time series model. The reason is that the simplicity and also the we just identify the black box. So it's very popular in the industry when we're working on the time series data. So in this video, we're going to look at, first of all, we're going to look at how we can creating ACF and PACF plots, because that's really a very simple diagnostic we should use when we are trying to identify what is our ARIMA model. And then we're going to learn how we can run the ARIMA model on the Python. Okay, so in order to do this part of exercise, you have to make sure you have the following three packages imported to your notebook. So the first is the oh, sorry, we don't need this one. So we only need the two packages. So the first one is plot ACF, plot PACF from these packages. It's called the stat models, graphs, stats tool plots. And then the second one is also from the same packages, but it's called the ARIMA. Okay, so those are the two packages you need to install, like import it to your notebook. Okay, so now we are still gonna working on the meta stock price. So if you haven't downloaded it, so make sure you download it. And then this is, like I said, this is a continuing video related to the previous one. So make sure you download and upload using this icon, and then using the function we have before called the meta PD rate CSV to import in this file to your notebook, to this notebook, so they can read it. Okay, so now what we're gonna do first is we wanna getting our ACF and the PACF. Okay. So first, I want to creating a diagram so that the ACF on the top and the PACF on the bottom. So you definitely can creating two separate charts. But here I'm to share with you how you can creating one chart but with multiple diagram in that. So that is use the subplots. Okay, subplots. I want to have two rows and one column. So one on the top will be ACF and one on the bottom will be PACF. And then the size is 8 by 8. And then I would need a two axis, axis 1 and axis 2, because one is for the ACF plot, the other one is for the PAC plot. We don't want to using the same axis, right? And then the plot is called creating one called a figure. And then the data we import in called a meta, right? So if you go up, make sure, okay, so it has to be capitalized meta. So I need to update here. Okay, here has to be capitalized meta. Like I said, in the Python, capitalizing a word means a lot. So if you capitalize, it has to consider you capitalize. And since the data, we have two columns. First column is the date, second column is close. So when we close price, so we only need to do the ACF, PACF for the price column, right? So therefore I call close. And then, so first I want to use plotting my ACF plot. So I use plot ACF. So you can see at the top, that's what you imported, right? This function is imported called the plot ACF. I didn't create in this syntax. So it's from the packages, okay? And then the second one, very similar. So the inside first, I tell what is the data called. So it's from the meta data frame and the column called the close. And I want to draw 10 lags. So in the forecast X, we use 12. And then by default, I chose 0, and so the axis, okay, here they go. Let me run it. Okay, here they go. We see on the top here is our ACF, the bottom is PACF. Okay, so based on this diagram, you can see that the ACF is never dying down. That means our data have trend. So I have some kind of trend. So if you go back to look at our diagram, you already see, yes, we already see this upward trend. It's not surprising. The data we are dealing with here is on stationary, right? It's on stationary. So we learn in the class, if the data is on stationary, we need to differentiate async the data, right? We need to differentiate in the data before we can apply ARIMA model. But the good thing is we do have ARIMA model, so we can define that I term, right? We need to differentiate async the data. Okay, but since we are working on the trials, so let me just try the ARIMA model that does not consider we need to differentiate seeing the data. Okay, so the function we are using to run the ARIMA model is called ARIMA, has to be capitalized. Okay, although we know for the order P, D, and Q, the D has equal to 1. Like I said, we just try first, see what we get. So I call this as a model. So there were a bunch of input, so it's not a data frame. So it actually has a lot of information about the parameter value, about the statistic test. But I define this as this result called a model. And then the function is ARIMA capitalized because that's the function we imported, right? They are capitalized ARIMA. And then the data I'm using is the meta data frame, the second column closed. So the order means the P, D, and the Q we learned in the class. So the P is your AR term. D is the second entry here, is the integration term, and the Q is last one, that is your MA term, right? Like I said, I'm just testing out. I know this one has to be 1, but I'm just testing out if I choose 0, what we're gonna get. So the second line is fitting the model, fitting the data to the model, and then the end is the printing our result for our this ARIMA model. Okay, so let me run this model. Here they go. This is our result. Okay, similar as our class, we are looking at a bunch of things. We look at AIC, BIC is pretty large, 6,770. It's hard to say, right? We're gonna compare later. We're gonna use it for comparison, and then we are looking at our Q test. Remember, the Q test is allow us to see if our data is stationary or not. So of course, the Q test here, this is the p-value, okay? The first one is Q statistics. And then remember in the class, we actually has to calculating critical value, but for Python, we already got a p-value. So for the Q test, so the HO is the data is stationary, right? So as we can, the data has no autocorrelation. And then as we can see that we actually rejected, so which is bad. So now you are thinking, what actually causing this? Okay, so the reason we have on stationary data is because we haven't resolving our stationary yet, and then we try to fit in a data. So based on the chart here, we believe our model should have one level integration, right? One level integration. So the differencing should equal to 1. So therefore, I'm trying the second model. I'm trying 0, 1, 0. Okay. Same syntax, but I just change it to 1. Okay, now as you can see, our Q statistic become 0.24. So by differencing the data, we are able to handle the autocorrelation. But again, that's not reason we cancel autocorrelation. It just means now our model seems like works well. The ARIMA 0, 1, 0 seem like working well. We no longer see the autocorrelation, and then everything look kind of right? But now, as you can learn in our forecast X, so we actually should go through a bunch of algorithm to determine which is our best model, right? So in order to do that, I'm creating this loop. Okay, creating this loop, and we're gonna base on the AIC and the BIC values to pick what is my best ARIMA model. Again, in our forecast X, they did this at the back end, but if you want to do Python, you actually have to manually code it. So first of all, creating this holding called a order AIC BIC, because I want to base on the AIC and the BIC to selecting my best model. And then I will loop through different value for P and the Q. So I want to just save my time a little bit. So I'm changing 10 to 3. So what happened here for the P, that is my AR term, right? AR term here. I wanted the model to try from 1 to 3 value. So 1, 2, and 3. The similarly for Q, I want to try the value 1, 2, and 3. So after the model run through, I will recording the value of the AIC and PIC value so that later I can base on the smallest AIC, PIC value to pick what is my best model. Okay, so for building this loop, allow me to developing, say, if I choose 3, so I will developing 9 different models, right? So it will be P equal to 1, Q equal to 0, sorry, P equal to 0. So actually 0, 1, and 2. sorry, 0, 1, 2, and 3. So I have 14 models. So then that would be the different combination between P and the Q, and I would be able to get in that amount of the ARIMA model. Okay, so also you notice that in the syntax I use try and except, because just in case I give some P and Q combination does not allow the model to run the result. I want to avoid that happen, because if that's happened, you will get an error term and your model will stop running because it's a loop. So I don't want that. I wanted to skip it. So therefore, I will try. If it works, that's good. Otherwise, I will just print out the P and the Q term, and then the AIC and the BIC will be blank. Okay, so having this try and except in the loop allow me to run through the loop without being stopped due to some circumstance you don't get in the result you wanted. Okay, so let me run this result. Okay, very quickly you can see we run through a lot of things. So the first combination is 0, 0, 0, 1, 0. So the P and Q combination. So this is AIC value, this is BIC value. Okay, AIC, BIC. So now, as we learned in the class, we want to pick the model that had the smallest AIC or BIC, right? So what we're gonna do, so of course you can eyeballing to see which one give you the smallest value, but of course that's not the best practices. How about you actually, like I said, initially I set up here as 10, so you're gonna end up a lot of rows here, so it's really hard to compare, especially the differences are very small. So now you want to sort in your AIC and the BIC value, right? So everything you come out here, you cannot sort it directly. The way you can sort in the value, you need to convert your data to the panda to the data frame. We did the same thing in the first video, right? Converting a list of the data to the data frame so that you can export into the Excel. The same, in order to sorting any data, you need to converting this result to a data frame. So that's pretty much what we did here. Is we first converting. We just creating this order AIC, BIC to a data frame, and then I will print it out sorted by our BIC so that we can pick our best model. Okay, let me run this cell. See, so now you can see the result here we have is sorted by BIC. So the top one, which gives us the smallest value, BIC is 0, 0. So when P and Q equal to 0, that gives us the smallest BIC. How about based on AIC? So I just need to change in here to AIC. Here they go. So based on the AIC, the smallest AIC value is under the P equal to 0 and Q equal to 0. So now under both AIC and the BIC, seem like indicating 0, 0 is our best model. So 0, 1, 0 is our best model. Okay. So now what I can do is I can do diagnostics using the plot. And so first, let me rerun the model again. So our best model, given the scenario we have here, will be the ARIMA 010 model. So I'm gonna run it again. So this is my best model. Now I want to developing the residual. Remember, we have some kind of situation we can develop the residuals, and to do the ACF and PACF diagram based on the residual. So you can using this function to get in the residual. However, here in this video, I want to introduce in the plot diagnostics. So this is more simpler because in this diagnostic plot, you will be able to see the plot you are looking for. Okay, we basically use the results because the result is the result coming from this model. Right, the result is model.fit, and the plot diagnostics. So and then plt.show that will able to show you different kind of diagnostic plot. So here they go, very smart, right? So in the class, we didn't use the first three. So basically the first one is look at the heterostochasticity. So as we learn, if the model had heterostochasticity, we will see the funnel shape, so we don't see it. But we do see a few outliers actually. When you see a very long line, that means we do have outliers. And then we have some outlier in my data. And then the second and third diagram here, so this one, they are basically in the model we assume the error term is white noise. That means they might follow normal distribution. And so as we're seeing here, it's hard to say whether they look like normal. But if we pay attention on the other one called QQ plot, so QQ plot is that if the data is following normal distribution, and you will be able to see there all the dot is laid around this red line. but we do see a few dots actually far away from this red line. That means we have some outliers. So very consistent, the first chart and third chart. And what I want to call out is the third diagram. So this is our auto relation. So basically it's our ACF diagram. So this is very important, right? We want to make sure after we apply the right model, we no longer see the the autocorrelation. As you can see, there's no line is outside my statistically significant band, which is like a shaded light blue. So if you go up here, similar result we can see based on our Q statistic is statistically insignificant, right? So therefore we are able to reject, we cannot reject null hypothesis. There's no autocorrelation. So basically for the metadata we have here, we find the best model to do the forecasting. That's our ARIMA 010.